Hello and welcome everyone to today's webinar on accelerating developer productivity with Oracle Autonomous Database. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. We're excited to kick off this series and to show you how Autonomous Database can help you simplify the development process while working with modern architectures like microservices. If you do not currently have an Oracle Cloud account, we've got a special promotion with extra credits so that you can try out Autonomous Database and follow along with the demo today. To access the promo, please sign up using the same email that you registered with for today's event. We'll also be recording the session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Oracle Autonomous Database that you can access at the QR code there or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for the webinar channel. We will also be checking the Zoom chat and the Zoom Q&A areas throughout the webinar, and we'll open up for live Q&A after the demo concludes. Today's webcast will be presented by German Viscuso, Director of Community Management. So without further ado, I will hand it over to German.
Welcome, everybody. So my name is German Viscuso. I'm the Director of the developer community around Autonomous Database. We'll get to know what Autonomous Database is in the session. Most of my time, I'm focusing on building a healthy developer community around Autonomous, or ADB for short, that's how we call it. For those of you who are curious what I do and what's my background, etc., before joining Oracle, I was a senior developer advocate and solutions architect at Amazon, and I've been in this line of work for more than 15 years. So this is what I really like and enjoy. So let's get started. All right. So let's discuss a little bit of the dynamics of the session, so you get to know what we're going to cover here. So quick look at the agenda. I will be using a few slides to give you background and prepare you for a couple of demos. The first demo will help us get up and running with ADB, or Autonomous Database. We will provision an Autonomous Database and see what we can do with it, some cool features with Autonomous. But close to the end of the webinar, we also have a second demo quickly showing how to set up Oracle developer tools for VS Code. So if you're a developer, you're probably familiar with Visual Studio Code, and for sure you want to use this great extension that we created at Oracle. After the second demo, I will quickly cover some observability with Grafana details. There are multiple and different topics that I want to cover related to development with Autonomous Database, so bear with me. We will cover a lot of things. But I will give you a chance to vote in the end on which ones you want me to cover, because this is the kickstart of a series, right? So this is the first webinar of a series, and it is on purpose a little bit more high level to introduce Autonomous and some of the foundations of Autonomous and the design considerations, etc. But you will have a chance to vote for what's coming next. So in any case, we'll get our hands dirty with demos, and I invite you to follow me today if you're already created an Oracle Cloud Infrastructure account, which you can do for free. So everything we do today can be done with the free tier of OCI, so don't worry, you don't have to pay for anything. Right. Okay, so let's get started with the evolution of application architectures. So let's take a high-level look at how we've been building applications in the past, let's say 20 years or so. If you've been around for a while, like me, you remember there were data centers with physical servers running what we called monolithic three-tier architectures. And that was user interface, business logic, and database or data store. Then came the data centers with incorporated virtual machines. Remember the era of the rise of the virtual machine that made it easier to go to the cloud. And so we started seeing VMware, KVM, etc., running N-tier architectures in the cloud. But this wasn't really cloud native yet, because these were the first shots at going to the cloud, right? And we were replicating a lot of what we were doing on-prem, we were replicating that in the cloud, right? Now, in the last 10 years or so, we saw the evolution of a cloud-based approach, I would say, several cloud-based approaches, where cloud has been increasingly used to develop and deploy microservices. If you see MSA, this means microservice architecture, and I'm going to talk a lot about it today. And so most of these modern applications that are running today run as microservices or on containers, and they are developed using DevOps processes and tools. But in the last few years, we have seen the rise of the serverless approach, where developers don't want to do any operational work. They want to go fully serverless. And the communication is done via events, you probably saw. That's why I mentioned here in the last column, EDA or event-driven architectures. Okay, so today we're using mostly a combination of cloud native and microservices-based architectures and event-driven architectures. So one thing we can observe in any of these architectures is the database. It's the common thing that we see inside the monolithic, cloud-based, cloud-native, event-driven. The database is always there. It is more or less abstracted depending on what time we're talking about, but it has always been there and will always be there. It's a very important part of the architecture. So the key here seems to be able to scale microservices, the microservices architecture, and the database is at the core of it. So we have to take care of how we are going to scale and how data is going to scale with these microservices. So before going further, I would like to ask a question. I would like to ask if you ever heard about Autonomous Database. So please raise your hand if you are watching right now, and if you heard about Autonomous Database. I want to get an idea of whether you basically heard about it, right? Okay, thank you, appreciate that. And I will be running a few of these questions to assess the audience, to put it some way, but I just want to give some space between these questions. So let's keep going. All right. So I mentioned microservices, okay? And I hope that most of you here are developers or have done some kind of development before, or really like the technical aspects of building a microservice or a similar architecture. So most of you should know how developers are leveraging microservices in modern architectures, but the idea is not new. The idea is about achieving low coupling and high cohesion at the service level. If you, like me, studied like computer science or programming or software engineering, that's my background, they always were telling us about achieving low coupling and high cohesion in components. Maybe when you were doing object-oriented programming, you had to achieve this at the component level. Microservices try to achieve the same thing, but at the service level. And we're trying to isolate services so we don't make services depend on each other, okay? So this is a good engineering approach. Now, imagine that I'm part of an engineering team, part of one specific microservice. I mean, I'm in charge of only one specific microservice. And the use case is data-driven. That microservice has to actually go to a database and fetch information and then make it available via the microservice. If I'm in charge of this microservice, I have the freedom to choose the database, and I probably go choose a database that fits the type of data that the service has to handle, right? So I choose different databases for different microservices. That can be a problem. And we often call this the database per service problem. So let us say you have different microservices here with a document database, a key value database, a relational database, spatial database, a graph DB, like Neo4j, for example. They're all written in different languages. And this is just 5 microservices, but what happens when you grow and see yourself running 50 or 100 microservices, which typically big companies do today? This basically leads to complexity in the architecture. You need to have specific skills to manage each one of these databases for each microservice. And you have to understand or at least have experience with different ways of dealing with data ingestion, data integration, data propagation, management of the database, security of the database, etc. So you have probably different models and different ways to do that depending on the database technology that you're using. So this complexity in the management and deployment of these databases comes with a cost. So how can we solve this? At Oracle, we created the converged database. And please raise your hands if you heard about converged database before. I would like to get an idea of whether you heard about it. What is converged database? Oracle has been adding converged database capabilities within the Oracle database for years now. The core idea behind this is that instead of having separate databases for each type of data, you have a multi-model database which supports key value, JSON, graph, spatial, blockchain, relational, etc., in the same database architecture. So when you combine this with a multi-tenant architecture, which is having pluggable DBs and having a container database, which you can quickly manage like a fleet of different pluggable databases, you can make it easy to handle the data integration, the management, security of the database, and make the underlying architecture of microservices simpler, as we'll see in a couple of slides. So suppose that you are able to handle security or maybe patching at the container level for all your different data types, okay? All your different databases, but you have to handle that in one specific way. And with autonomous, and we will see what autonomous is, things become even easier. All right, so we often see this trend where as new data types emerge in technology space, new solutions pop up, specialized products that handle just a specific use case. And that happened a lot during the NoSQL era. I was there and I was working for an object database company at the time, and we were seeing specific databases and database technology popping up to solve some very specific use case. And for that use case, they were awesome, right? Because they solved that specific use case. But even though they were very fast, very specific, and everybody was embracing that specific technology, the consequences were not understood. So this was typical of the NoSQL era, as I said. But a converged database incorporates native support for these data types and can run all sorts of workloads, from IoT to blockchains to analytics to machine learning, et cetera, et cetera, et cetera. And you are able to handle a lot of things in a common shape, in a common architecture. So you don't have to deal with the very specifics of maintaining different database technologies. So this is an example of all the data types that we are handling today within Autonomous Database, which is Autonomous Database. It is an Oracle database. And I will go into that in a couple of slides. So let me give you one example of converged database. This great example is how to use converged database capabilities with the MongoDB API for Autonomous Database. So it is an implementation of the MongoDB wire protocol. So you combine JSON documents and collections, and you combine it with this specific protocol where you can use your existing MongoDB expertise to actually query JSON documents and handle collections, et cetera, et cetera. So you're working with Autonomous Database, storing documents as if it were a MongoDB, but the underlying database technology is Autonomous Database. So what is this giving us? Like, for example, you could go and query JSON documents just using SQL if you want, okay? So you still have the underlying capabilities of the Oracle database. So enough of converge to try to cover what converged database is. What is Autonomous Database? So Oracle's Autonomous Database leverages the Oracle converged database for simplified architecture and operational model. So Autonomous Database is the Oracle converged database, but it also makes the DB self-service and pay-per-use by putting it in the cloud. So it is cloud native and it's backed by the fastest database to hardware that was ever made, which is called Exadata. And this gives me an opportunity to basically ask who heard about Exadata. If you heard about Exadata before, please raise your hand. When I joined Oracle some time ago, I was scratching my head and saying, what is Exadata? I had no idea. Sometimes the underlying technology that makes these things possible, or Autonomous Database possible, it's not widely known, but Exadata is a big thing on Autonomous. So it's database tuned hardware that is extremely fast and extremely prepared for handling Oracle database. So we mentioned converged database, we mentioned cloud and Exadata in the cloud, and now machine learning. So we add that to the mix. We add machine learning to do what? To basically automate a lot of the things that are things that you will have to worry about, like tuning the database, scaling the database, securing the database, patching the database. You mentioned it. So you don't have to spend time doing all these things. You can focus on building and deploying applications. So this three things, is autonomous database. Just to give you a very quick and rough analogy, it's like think about the self-driving car, but taken to the database. All right, so I said that autonomous database has a strong focus on automation. So these are all the capabilities that we are providing. So you don't have to worry about any of these at all. So as you can see, we can do automatic tuning, like auto indexing, for example, which is awesome. Automatic provisioning, automatic scaling, automatic encryption. You don't have to worry about patching, updating, maintenance is scheduled automatically for you, et cetera, et cetera, et cetera. So you're always up to date with the most, let's say, performant version of your database and the most secure version of your database automatically. So enough of the explanations. Let's go to the first demo now. But first, let me show you a quick, let me give you a quick rundown of the autonomous database architecture. So if you run into these components when you're dealing with the cloud console, because we will go to cloud.oracle.com, which is the OCI console to do the first demo. If you run into any of these, you will at least know what we're talking about. So first of all, let me tell you that autonomous database comes in two flavors, shared and dedicated. Those are deployment options. So with shared, which is mostly what we will see today because it's super easy to provision, and basically we can provision in 2 minutes and go quickly over it. There are a lot of common things, but shared is one of those cylinders that you see in the image, and it's basically one pluggable DB. When you see ADB1, ADB2, ADB3, you can basically provision one of those without having to provision any of the autonomous VM clusters, Exadata infrastructure, any of the containers that you see there. You don't have to provision any of that. And that's what shared is. It's your own particular and specific autonomous database in the cloud, and you don't have to worry about anything, okay? Sometimes you want a specific control, you want more control, and you want isolation from tenancies, and basically you want to be able to provision the whole thing from the very basic, which is you provision the Exadata infrastructure yourself. So you go to the cloud and say, hey, I want to create one X9M Exadata machine, and you create it in the cloud. Then you can create a specific autonomous VM cluster within the Exadata infrastructure. And within the cluster, you can create a container database, which is this pluggable architecture that I mentioned before, which is, it will be a container of these pluggable databases or autonomous databases. And then you can go ahead and create specific autonomous databases. And in this way, you can basically isolate how you work with the database. If you use autonomous database dedicated, which is what I'm explaining right now, where you can provision everything from the very bottom to the very top. And you can, for example, have fleet managers provisioning VM clusters or container databases. You can have developers basically automatically provisioning on a self-service basis specific autonomous databases within containers. So this is an example. When you want full control and you want the whole architecture for yourself, you go with autonomous database dedicated. And when you just want to work with one isolated autonomous database without worrying about anything else, you go with autonomous database shared. Okay, so we will run into some of these concepts: the Exadata infrastructure, autonomous VM clusters, autonomous container databases, and autonomous databases themselves. All right, so time for the demo, and I'm going to cloud@oracle.com. So we will continue here and we will sign in, okay? So I have a tenancy here. All right, so this is OCI, Oracle Cloud Infrastructure. It's a cloud where you can provision multiple things from compute, databases, etc. Okay, so what I'm going to do now is I'm going to click I'm going to make sure that I'm in the Phoenix region, which is where I have resources, etc. I'm going to go to the hamburger menu, okay? And I'm going to click on Oracle Database, all right? So when I click on Oracle Database, you will see that I can actually choose Autonomous Database, okay? And we have the different, deployment options for Autonomous Database, the different workload types for Autonomous Database. So what I'm going to do is I'm going to make sure I'm in the CDN compartment right now, and I'm going to create an Autonomous Database. So create Autonomous Database, you'll see that there was one database there already. But this is what you get when you're creating an Autonomous Database. So you can change the display name. I can add my name there in the last part. You will see that you can choose a workload type. And what is a workload type? The underlying technology is the same. So it is an Autonomous Database, but you can have it configured for a specific type of workload. If you want to host analytics data, like a data warehouse, the database is optimized, the memory, etc., is optimized to use columnar format, optimized for queries rather than transaction processing, etc. You can choose transaction processing, and you get it optimized for the typical database that is being hit with transactions, all the time. Like maybe you're selling stuff or something like that, or you can actually choose JSON type of workload if you want to store documents, or Apex, which is a way to quickly develop applications, and it's very specific. So the underlying database is not changing. What it changes is the configuration to make it optimal for this specific type of workload. Okay. So then it comes the deployment type selection. As I mentioned, you have shared and you have dedicated, right? So if you want to quickly create one, and we want to quickly create one right now, you will choose a shared, for example. And if you want this database to be always free, and even though you run out of credits after you get this really nice deal with using this $500 with the tenancy, etc. Even if you want to keep databases always free, you can do that. Okay, you can run an always free Autonomous Database. It obviously has limitations, but you can have up to 2 Autonomous databases that are always free forever. Okay, so this is something I wanted to mention. Obviously, you are limited in the resources that you can assign to. Okay, so we have the ability to choose the underlying Oracle database. So Autonomous Database, it is an Oracle database behind the curtains. So you can choose, for example, in this case, 19C, but as we have more versions, you will be able to choose different versions. And you can choose the compute and the storage. So those are the 2 parameters that at the very fundamental level define your Autonomous Database. The number of CPUs that you have in order to have power, and performance, and the amount of storage that you have in order to actually store the data, right? So in this case, I'm going to go with 1 OCPU, which roughly translates to a physical core, to give you an idea, the OCPU, and 1 terabyte of storage. But I also have this, which is very interesting, which is auto-scaling. And I can basically choose that I want to enable OCPU auto-scaling, which is the CPU auto-scaling, and also the storage auto-scaling. So the database is fully elastic in the sense that you can make it scale automatically when the database is being hit by a lot of, let's say, a lot of requests. How does it work? In this case, we have a policy for auto-scaling where we can go, you can go up to 3x of the assigned amount of CPU and storage. You can go up to 3x if there's a peak. For example, if you're facing a peak, time where you're being hit heavily on the database. Okay, so then I will go and create an admin password. Let me do that now. And of course, as I said, you can follow me. If you want to create your first Autonomous Database in your OCI account, you can go right now. You can choose Oracle Database, Autonomous Database, and you can just follow and do the same thing. Okay. All right. So now it comes the network access, and this means how secure I want this database to be. I have several options here. So as you can see, I can have like a private endpoint that I can only access from my VCN. I can also allow specific IPs, as you can see here, or I can allow secure access from everywhere, meaning that if I have the right authentication credentials to actually access the database, I can connect to it no matter where I am. So that's what I'm going to choose right now, which, by the way, is the least secure option, right? As you can see, because this is not very secure that anybody can connect from anywhere, we are basically forcing you to use mutual TLS, MTLS. So this will be a wallet-based authentication, okay? Okay, so we keep going, and we are almost done here in the end. So you can choose a license. For existing Oracle users, you can choose bring your own license. So suppose that you have an Oracle Database Enterprise Edition license, or you have an Oracle Database Standard Edition license, you are entitled to CPUs here and to storage here, given the license that you already have. So you can use that option, right? But if you have nothing to do with Oracle, you never had a database, or you don't have a database, etc., you can still use this. You can use license included, and you basically pay as you go, right? The prices, if you have Oracle licenses, are slightly cheaper, or I would say not slightly, but they are cheaper, okay? So I'm going to go with license included. You can enter a contact email, etc., etc. So I'm going to just click on create right now, okay? Create autonomous database. And this is, I have actually measured this. This is provisioning right now. So this is going to take 2 minutes, okay? To give you an idea. So as we leave it provisioning, which is going to be around 2 minutes, I'm going to explain a couple of things, okay? So this is our Oracle database in the cloud. So right now, I will be able to access this Oracle database with any tool that I typically use for accessing any Oracle database. Like, for example, SQL Developer, anything that I use to basically do SQL over the database, I can actually go ahead and use the database connection details that will show up here in a sec when it ends provisioning, and you can connect to this. So it's a very quick and very easy way for you to actually spin up a database, a very powerful database, I must say, and you don't have to worry about all the admin because it's autonomous. There's a lot of things that are being done automatically for you. You don't have to basically come and tune an index, for example, if you had experience with relational databases. That's going to be done for you automatically, okay? Okay, so I'm seeing some of the results of the poll. You will see, you get more details about all of these specific aspects, okay? All right, so let me see what else I wanted to cover here. Okay, so autonomous data guards. You can enable autonomous data guard here. I'm not going to do that right now, but basically you can have a standby copy of this database automatically, and you can fail over to it if there is a problem. So if you enable this with just one click, and there you go, it's it provisioned, right? Now the database is available. And we went with autonomous data warehousing, which is basically the option to store analytical data. All right, so suppose I want to have, if I run into an issue with this database, I want to have like a standby that I can quickly switch over to the standby. I can enable autonomous data guard with one click, and I basically have that automatically, completely automatically. So I can fail over to it automatically if there's an issue. So suppose the system detects an issue and makes the failover for you. You don't have to come and click and anything, but you can also do manual failovers and say, okay, this is my primary, this is my secondary, and I can switch, back and forth. Okay. The good thing about when this fails, suppose that this fails and you go to the secondary database, that that secondary database becomes the primary. Suddenly, the users do not perceive any issues. They continue working, and the system quickly provisions another secondary database for you automatically, so you're covered again. Okay, so this is really nice. All right, so as I mentioned before, this is a full-blown database, and I have connection information here. So I click on database connection. Okay, here I have the TS name and connection strings that I could use, as you can see here. But I can also download an instant wallet. Okay, and there are some requirements to use wallets, but you are covered if you're using JDBC thin client or relatively new version, if you're using Python for Oracle driver, etc. So there's something I'm I'm going to show you in a bit where there are different options for you to connect to the database now that we have provisioned it. Okay. All right. So I'm going to show you database actions. Okay. Obviously, here we have stop, restart, etc., etc., etc. We can terminate it, and we have different tools that have been configured for you. So as you can see here, if you click on tool configuration, you have URLs for you to access specific services like database actions, which is here I have a shortcut for it, okay? But I also have Graph Studio, Oracle Machine Learning. Oracle Machine Learning is super interesting because we are running more than 30 machine learning algorithms within the database itself. So we actually took existing machine learning algorithms and optimize them to run in the database. So you don't have to be moving data outside the database to actually do your machine learning, but you basically bring the algorithms to the database so you can do the machine learning. And I hope that this could be one of the follow-up sessions where we can actually take a look at everything that you can do with Oracle Machine Learning. You also have data transforms, and here you have the direct link to go to the specific functionality where you can design graphical data transformations, to move data, etc., etc. You also have web access ORDs, and this is REST API support, and I'm going to show you a little bit of that now. MongoDB API and Soda drivers, which is this is for accessing graph kind of data. Okay. All right. So let's go back. Let's go to database actions right now. I'm clicking there, and you can see launch DB actions. Okay. All right. So it's launching. All right. So database action is very interesting because it's like a whole menu of things that you can do with the database. Now that we have this database, we don't have any data yet, but we have all these tools that we can use. Right? For development specifically, we can do SQL, Data Modeler, REST API, Liquibase, and I hope we can cover that later in a session. JSON documents, collections, etc., charts. So full of different services. So what I wanted to show you today is how you can go to the Data Studio. Okay, so let's go to Data Studio here, and you will see what Data Studio is in a sec. And as I said, we don't have any data in the database, right? So let's try to load some data with Data Studio. Okay, so what I want to do is load data. What I'm going to use is I have a local file. I can go to a cloud store. For example, I could go to an S3-based cloud store and basically grab data from there. I could go to a different database and bring my data from another database if I want to just do a migration, for example. But I could use a local file. I have a CSV file with customers, invented customers, and I'm going to drop that here. Okay, so I do next. Okay, it says drag and drop here to upload, and I have my file here, which is a very simple CSV, as I mentioned before. So let me see if I can locate it now. One sec, there you go. Customers.csv. It's processing. So it's offering me to create the table customers. But what happened here? So I want to take a closer look about what this is doing. So I click here and I go to settings. And as you can see, it basically detected all the columns in the CSV. This is just a plain CSV, right, with the column names and the data, and basically assign a column, a specific column for each of these elements, and also a data type for each of these elements. Of course, I can come and change this to numerical, etc. I'm going to just leave it as it is. So it's basically telling me the format, UTF-8, etc., etc., etc. All right. So we have some other things here, like a preview. This is what the CSV looks like. Okay. I can even see the SQL that is going to create this table. So it's giving me the SQL for me, etc., etc. So I'm going to close, and I'm just going to run with it. So I click on Start. Okay. Do you wish to run the data load jobs? Yes, run. Okay, so it's running. Took a couple of seconds. All right, and I am done. So now I want to see that that table is there and that data is there. So what is it that I'm going to do? What I'm going to do right now is I'm going to click on this, going back to database actions. Okay, overview. Let's go back to database actions, and I'm going to click on this SQL box here. Okay. All right. Some tutorials recommended me that I do not use the admin user to do this. You can actually create a different user and work with a different user. So there you go. I have the customers table here with all the different elements or all the different columns. And if I do select, select everything from customers, and I click play, you can see that we have the data here. Okay. All right, but that's not all. I wanted to show you something else, and I'm going to cover this in. I have a few more slides after we are done with the demo. Okay. So I wanted to cover sorry, one sec. I wanted to cover how to enable REST and how to basically make an API expose this table as an API. Okay, so what I'm going to do is I'm going to click on right-click on customers, REST, enable, right, and the alias is going to be customers, as you can see here, and I'm going to copy this URL. Okay, to copy this URL, and I'm going to click on enable. Notice that I did not click on enable authentication. So I'm basically opening this up without any kind of authentication, which is not a good idea. So that URL that I copy, if I go here, can click on it, and I'm basically getting back this as a service. So you can actually, if you're using Postman, for example, you can actually tap into this and extract the information. Okay. So one more thing that I wanted to show you is let me see here. Okay, so suppose that I want to insert something here and I want to do a post. So I go here to REST and I go to core command, for example. Let's see this, and I'm basically getting the core command for this. And if I click here on post, for example, I can fill the different data, like, I don't know, an ID, and I'm going to go with none here because I don't want to just fill the same. But basically, as you can see, this is being filled in automatically in the box below, right? So it's basically creating the post for me. All right. So I call this GRSS just as a customer ID. So I have a core command right now. And if I go here and I put this core command here, I click on enter, and I basically inserted that element into the service. So this is a REST API that we are using, and we call this auto REST. So it's basically automatically creating REST interfaces from tables. Obviously, ORDS is much more powerful than this, but this is just one example. Okay. So I mentioned that you can create containers to basically host these databases, and you can use that to orchestrate development, test, production, and operational life cycles like security, patching, etc. So instead of having multiple database types, as you can see here, we can simplify all of this by having one autonomous database architecture. So we have containers that host multiple pluggable databases for each of your microservices, and each of these are running their own data types. As you can see here in the picture, you can see JSON, you can see relational, you can see graph, etc., etc. So this makes it easier for you to secure it, easier for you to manage it, easier for you to integrate data between the databases. And I mentioned a bit of this before. So these containers make it possible to separate data and functions into microservices, but yet share a common operational model and identify other challenges like integration, maintenance, security, et cetera, and analytics. So notice how you can do cross PDB. So PDBs are the specific databases, how you can do cross PDB queries for analytics. As you can see here, I have analytics, and I'm basically going through all of these databases for analytics. So you can do analytics even among different data types, which would be very challenging if you were using different database technologies here. And notice also that we are doing message passing via TQ. Okay, so transactional event queues, this is TQ means transactional events queue, can be seen as Kafka within the database, which comes with advantages for microservices, as we will see next. Okay, so let's move on. All right, so I mentioned transactional event queues. For those of you that never heard about Oracle's TQs and transactional event queues and advanced queues, the concept is simple. It comes from the transactional outbox pattern. And if you come from microservices background, you might have heard about it. It's a documented pattern in microservices. What is known as event sourcing means that every time you touch the data, you need to send an event so other microservices can act on it. Suppose that you are updating customer information or something like that. You basically need to send an event saying, hey, this customer has been updated, maybe for other microservices to react. But as events are separate from the database, how can you make sure that you do both, the modifying the data and sending the event atomically? Problem is, what happens if you maybe modify the data, but you never get to send the event because there's a failure there, or the other way around. You think you modified the data correctly and you are sending the event in parallel, but maybe the data modification failed and you send the event saying this is modified. So when you are dealing with event-driven architectures, it's very important to do the event sourcing for when you are working with data atomically. So one solution is to use transactional capabilities, the transactional capabilities of the database itself, by updating a table of events. As you can see here in the graphic, we have the order table, which is what we need to, suppose that we need to create an order to order something, but we also have an outbox table, which is basically a table that stores the events related to that order table that other microservices will have to consume. So if we use this pattern, which is using a specific table within the database, we can make sure that both things, which is modifying the order table and creating an event related to that modification, happens in a single transaction. So in this case, it's all or nothing. Both happen or none of them happen. There's also no blocking two-phase commit. You don't have to basically, go through a series of steps to back and forth to make sure that this got done by blocking the transaction or anything like that, and the order of messages is preserved. So this is the basis of transactional event queues, which is the evolution of what we used to call Oracle's advanced queues. Let's take a closer look at that. So transactional event queues are basically providing a Kafka-compatible architecture with topics, partitions, etc. Raise your hands if you are familiar with Kafka, how Kafka works, please. Let's see if we have something. Okay, so Kafka has to do with with event sourcing, and Kafka is the message broker, and it works by working with producers and consumers. Okay, so the producers would put information in these channels or in this basically like let's say rooms within the Kafka broker, and the consumers will be able to go and consume that. So it's a message passing, and it's a message broker. So Thanks to transactional events queues, we can treat each autonomous database instance as a Kafka broker, and we are improving on its functionalities. So you can connect all the databases together and have messages or events propagated across different database instances or brokers, and you can have consumers connect to their nearest database instance. So this really scales out nicely. There is also a Kafka connector that allows you Kafka clusters. As you can see here in the bottom left, you have the concept of Kafka cluster, which is aggregating a lot of brokers working together. So we can also participate in a mesh, in an event mesh configuration. And the transactional event queues basically provides a Kafka Java API that you can use, and you can use Kafka-like REST APIs. So you can, in effect, you can replace a Kafka broker by using transactional event queues, with the advantage of this being very close to the database and very robust, because I already explained the transactional event outbox pattern, right? So this happens very close to the database, and it's very robust, and you're using the robustness of the database itself to basically make sure that this broker is always there, and it's obviously Kafka compatible, okay? So with all the event handling being inside the database, you are gaining a lot, because you are bringing the event streaming closer to the data, and that translates into speed. You can make the combination of data and related events more consistent, and you can bring the high availability, as I mentioned before, the high availability guarantees of the database to your message brokers. Okay, so I'm going to allow you to vote in the end, in case you want to have a specific session of the TX event queue. We can run a full-blown session explaining how the transactional event queues work and how you can leverage them to do message passing, etc. All right. So just to wrap things up, you can see in the column on the left how working with standard Kafka would translate into using more code, because you will have to basically create a lot of code to make sure that you are not duplicating these events, that these events are happening only once, and that these events are not being sent when the updates of the data actually fail, if you're working, for example, with MongoDB, Postgres, etc. And in the right, when you're working with the converged architecture and transactional event queues, you don't need to create all this code to basically make sure that you are not doing duplicate events, etc., etc. There's a lot more of boilerplate code if you are just dealing with standard Kafka and not with transactional event queues. All right, so sometimes you need to make microservices that are different work together. I suppose that we have a hotel booking microservice, and we need to make it work with the flight microservices for booking flights, and you are organizing a trip, and you have a system that basically needs to book the hotel and the flight together at once, but not one of the other. Basically, you need to make sure that both happen. You get the hotel and you get the flight, or none happen. Okay, so if these microservices are very different, and you can see them in the bottom part of this graphic, right on top of the databases, you'll see a hotel application created with Java and a flight application created with Node.js. Sometimes you need to make sure that both happen at the same time. So we created a library. With this, we're trying to help developers when consistency needs to be guaranteed across microservices. So we created this library called MicroTX, or also called Transaction Manager for microservices. So this is a completely free library that ensures that several ways of data consistency across microservices. And as you probably know, you're probably familiar with this, but sometimes this is a challenge to provide consistency among consistency in transactions when microservices are very different and maybe far away, right? Like in this case. So this system is basically providing a library where you can use it as the coordinator. So this is a coordinator that includes a bunch of transaction protocols and use APIs that allows your microservices to actually connect with this coordinator and allow it to basically orchestrate the microservice, the whole microservices transaction. In this case, you can use like a reservation protocol where you can allow Micro2X to make a reservation for the hotel without actually booking the hotel for real, make a reservation for the flight without booking it for real, and then communicate back with the services to actually say, hey, okay, give me the resource because I have made sure that this will happen together. So if you are interested, we can also go and do a specific session focusing on Micro2X, and you will probably hear when you hear about this type of libraries about long-running actions, which is related to the Eclipse Foundation, and also sagas. You probably heard about sagas before. So it has to do with coordinating different microservices and making sure that things happen atomically and consistently. Okay. All right. So this is one of the final topics, and then we'll go into the VS Code demo. So DevOps. It is another topic of interest for developers, obviously, and please raise your hands if you work with DevOps processes, tools, methodologies, if you have some familiarity with DevOps. All right. That's great. That's great. Thank you. So we provide comprehensive APIs to instrumentalize database operations. We also provide metrics and events for observability. We support containerization and infrastructure as code, and also very good ways to monitor the database with dashboards, etc. This is just generic info, but I want to go into specific things that we have right now. So if you take a look at this slide, you will see, and this is something we are doing all across OCI, we are providing Terraform providers for all of our infrastructure, not only for autonomous database, but for everything. But in this case, you can use OC Terraform providers for autonomous database, where you have a specific distribution, including Terraform Cloud, to be a Terraform code, basically deploy the database, admin the database, you name it. You can do whatever you want, and you can do it all with infrastructure as code. So we also have Ansible. I'm not sure if you used Ansible before, but this is a way to, it's very popular in the Linux community, and it's a way to handle inventory of resources maybe within the cloud. Like, for example, you can have specific, I don't know, VMs, you can have a specific infrastructure, you can have a specific VPNs, etc. And you can run all of that as inventory. And we have playbooks for autonomous database that you can use within Ansible. So this basically allow you to do all the inventorying of all the resources that you are using for autonomous specifically, with all the maintenance, etc., etc. Now, if you are familiar with DevOps, you probably heard of Jenkins, which is a continuous integration, continuous delivery tool. Okay, we have two plugins. One's called OCI Jenkins Compute, and the other one is OCI DevOps plugins. And this allows you to deploy autonomous database as part of your CI/CD pipelines. So if you want to quickly create an autonomous database to just test, put some data in it as part of your DevOps operations, and then terminate it, you can do that via Jenkins, which is pretty cool. We also have liquid-based automation, and liquid-based is a way for you to track the schema versions of your database. You can track and deploy specific schema changes of your database, and sometimes you are doing modifications and you want to revert back to a previous schema, and liquid-based is a great way for you to actually do that. And also provides real-time monitoring and visibility over the database. And we have integrated that with SQL CL, and we are providing like a liquid-based version inside SQL CL, which is on steroids. It provides more than the typical open source liquid-based version. We can also do a session around that if you are interested, and we could go through Liquibase inside SQL CL and do a lot of things in that session. So Grafana visualization. We have Grafana plugins that expose a data source for visualization. I'm going to go into more detail on the specific plugins that we have. We also have Prometheus support. Prometheus is a time series database, and this is super related to Grafana, and it's a great way to basically send events to Prometheus and then consume them from Grafana. Okay. All right. So ORTs, this is something that I wanted to show you, but I couldn't because database action did not launch. But basically what I was going to do was to put a customer's table in Autonomous Database and then expose the table as a web service. We can do that thanks to ORS. There's a functionality in this Oracle RESTful Data Services called Auto REST, which basically allows you to quickly take a table and create a REST web service from it, even including authentication, etc., etc., etc. So if you are interested, you can go to oracle.com/orgs and you can take a look at how to do that. But we can also do a specific session going through all the functionality of ORGs. So we provision, during the demo, we provision an autonomous database, but you probably want to connect to the database. There are multiple ways in which you can connect to the database. We have thin clients for JDBC, for example. Here, the important thing is that what you see in red are Oracle-provided drivers. What you see in white are open source drivers, and what you see in green are third-party open source drivers. So as you can see, most of them are built on top of the Oracle Core Call Interface, OCI Oracle Core Interface. But the Oracle Core Call Interface, which is a C type of interface, is kind of complex. So there's an open source project called ODPI-C, which builds on top of it and makes its usage more simple. So a lot of folks are basically building their drivers and their connectors on top of ODPI.C, like Python, Node, etc., etc. So it's easier to actually deal with this level of abstraction that directly with the Oracle Call Interface. But as you can see, almost any language, there are more, we're listing a few of them, but for almost any language, you can actually connect to the Oracle database, and you can use the same, for autonomous, you can use the same ways to connect, okay? All right, so let's move on. And now we go into what I wanted to show you, which is the Oracle Developers Tools for VS Code. So if you go to Visual Studio Code, you go to extensions and you type Oracle, you will see that there's an Oracle Developer Tools for VS Code. And it provides management capabilities. So for example, you can create databases, you can terminate databases, etc., even autonomous databases, but also on-prem, if you provide the right connections. But it also allows you to do SQL when you connect to a database. So let's take a quick look. Okay. Okay, and let me just go through this. So first of all, what you need to do if you want to install the VS Code extensions for Oracle, you need to go to this link here, which will be part of the resources section later, and the part of the links that we're going to share, and install the OCI CLI. So for me, for I'm a Mac user, it was very simple because I just went with brew and just did a brew install OCI CLI. Okay, so let me just go bigger here just in case. So once you have installed the CLI, you need to provide a way to connect to a specific tenancy. Okay, so what you have to do is you go to the Oracle Cloud. So let's go to home. Let me quickly show you how to do this. Let's close this. You go to the profile and you click on My Profile here. So if you do that, you will see here API keys, right? And remember that you can still do this with the free tier. So I have created one, but suppose that this is empty. You can do leave this selected, generate API key pair, and you would just download the private key. When you do this, you get a PEM file. So the PEM file is something that then you can come and place in the, let me just go bigger, okay. Okay. So as you can see here, I'm in my home directory, of the home directory of my user, and there's a .oci directory that gets created when you install the CLI, and you just place the PEM here, which is this Herbux PEM, place the PEM here, and you need to provide these two things, the PEM file and the config file, in order to be able to connect to OCI. So how do you provide the config file? Because we already have the PEM. So what you do is you go here, you click on the three dots once you created your pair, and you click on View Configuration File. You copy this text here, and you place it in the config file. Okay, so this system is giving you the config file already. So the only thing that you need to change is the location of the PEM file, which is here, key file. And here, as you can see in my configuration, I'm going to do cat config. I just basically pointed the key file to the place where I put the PEM file. Okay, so key file and the PEM file. Once you've done that, you can actually start running OCI CLI commands against your OCI tenancy. But you can also run the autonomous database. You can also run the Oracle Visual Studio developer tools. So this is already done here. If you go to autonomous, and if you want to do it like right now, you go to extensions, you will type Oracle, okay, and you will see Oracle Developer Tools, and you will click on Install. If you do that, the system will automatically detect the OCI CLI installation and configuration. I will basically connect to OCI, so you don't have to do anything if you properly set up the OCI CLI. Okay, so I'm going here. Then you will see this cylinder here. That will be a new item in your Visual Studio Code, and you will see your tenancy here. Okay, so I am refreshing now my tenancy, and you will see this automatically if you configure the OCI CLI correctly. And if I click here on Autonomous Transaction Processing Database, I can see the database that we just created. Okay, so if I do right click here, I can basically start, stop, and terminate, change the password, etc. I can also download the credentials files if I want to. But the good thing is I can also do right click here on Autonomous Database, and I can click on Create New, for example. And I can basically go with the defaults, provide an admin password, and click on Create Autonomous. And now I am doing the same thing that I showed you from the console, from the OCI console, but I'm doing this from Visual Studio Code, and I am creating a database. So this will roughly take 2 minutes again. So we can actually close this. But suppose that I want to connect to this database, the database we created. There's no double click here. We just need to go through these steps. This is something I wanted to show you. You need to click on Create Connection in Database Explorer. So what you would use is Database Explorer, okay? Create Connection in Database Explorer. You get this screen where you only have Instance Wallet, which is wallet-based connection, because we are using an always free database. The system also supports wallet-less authentication via TLS, but that only happens if you're not using a host-free database. As you can see, the other database is already provisioned. The other one we just created, okay? And it says created successfully here. Okay, so going to the connection, I click on download, and I am getting the wallet. So now I enter the password. Okay, so I now click on create connection. There you go. So all good. I created a connection. Now I do this. I enter the password again. Okay. As you can see, we have the tables here. We have access to everything, views, procedures, triggers, etc., etc. So we connected to this autonomous database. And if I expand tables here, I go to relational tables. I can see the customers table that we created before with all the different, let me expand this, with all the different column names, okay? And if I do right click here and I select show data, for example, I am taking a look at the data within the table. But that's not all. For example, you could do a right click here and generate an insert SQL statement, for example. And there you go, it will prepare it for you, okay? So this is more or less what I wanted to show you. I mean, we could probably go deeper to see all the functionalities here, but I think this is a great summary to understand how to admin autonomous databases from this extension, and also how to do basic SQL, as you can see from the extension. Because if you do right click here, you can also create delete statements, create statements, select statement, etc. So it's basically full SQL access. Okay, so let's stop it here. So I'm going to wrap it up with observability. And usually when we talk about observability, we talk about metrics, we talk about logging, and we talk about tracing applications. So this is something we are providing within OCI. There's a monitoring service within OCI that's basically providing metrics for all the services, including autonomous database, and also logging events for everything, okay? So I mentioned Grafana before. We have 3 Grafana, and if you heard about Grafana before, please raise your hand so I get an idea. Okay, that's good. Okay, that's great. So we have 3 plugins for Grafana. We have one, it's called the Oracle Database plugin, and you can access this if you go to the Grafana Cloud. You can actually type Oracle, and this 3 will pop up. The Oracle Database plugin is a commercial plugin. It's closed source, and you have to pay for it when you're using Grafana Cloud. Basically, allow you to create the TCP connection to the database to monitor it. So it is really cool because it allows you to run and modify SQL. You can basically send SQL to the database, and you can convert those SQL results into visualizations in your Grafana dashboard, okay? But this is connecting to the database itself. Then we have 2 other plugins that we are maintaining called the OCI plugins, which is one for the monitoring service, which is the OCI metrics plugin, and the OCI logs plugin, which is the one to monitor the logs. So you don't connect to the database itself, but you connect to these 2 services that are running within your OCI tenancy, which is the monitoring service and the log service, and you extract information from those services. So these 2 plugins, the metrics plugin and the logs plugin, allows you to basically allows you to visualize anything from your tenancy, not only autonomous database, but any service that you want to monitor. These last 2, the OCI plugins, are open source, and they are available also within Grafana Cloud Pro. Okay, All right. So one last thing that let's just two more minutes, and we are done. Okay. So we created something called Prometheus Grafana for Oracle. And if you like to work with containers, if you like to work with Kubernetes, etc., what this is providing, and it's open source, you can see the URL there. So what this is basically providing is a way for you to spin up a Kubernetes container that connects to the database, in this case to Autonomous Database, but you can actually connect to multiple types of Oracle databases, and extracts information from the database, and it makes it available as exporters. So this is providing a tracing exporter, a metrics exporter, and a logs exporter. So these exporters can basically place this information in a Grafana dashboard. So if you want to create a container-based solution for observability, where you spin up a container that's basically monitoring Autonomous Database, and then you spin up a container that's basically running your Grafana instance, for example, this is ideal for you. And this is all standard space. It's using OpenTelemetry, etc., and very popular libraries like Jaeger and Prometheus, Grafana Loki, etc. Okay, so the last thing that I wanted to show you is the Aura operator. Now that we are talking about containers, we created Oracle Database Kubernetes Operator. And if you're doing DevOps and you're for sure working with containers, and we have this really nice way going Kubernetes native with your Oracle database. So Aura operator extends the Kubernetes API with custom resources and controllers for automating Oracle database lifecycle management, including all autonomous database deployments. So you can stop a database, start a database, you can create a database, etc., using basically commands that are Kubernetes native. Right? So it's like the same way in which you spin up containers using the Kubernetes command line, you can actually do that and spin up an autonomous database. So this is our way of getting closer to Kubernetes. And you can do that with any Oracle database. Okay? So this is it for me. I apologize for the problems with the live demos, but if you are really interested about seeing something more specific about what I just showed you, you can actually vote for these sessions. You can send me a message on Slack on the Autonomous event, or you can actually go through this poll that Tara kindly prepared for me. So we can go in the next session and go and take a look at the MongoDB API, for example, how to use the MongoDB API with Autonomous Database. We can go and take a look at how to connect to Autonomous Data from an Node.js application and basically use an Node.js library to connect to Autonomous. We can go deeper into microservices with transactional event queues, which is that system that provides Kafka-like functionality within the database. We can also go take a look at that MicroTX library that I mentioned before to actually orchestrate microservices that are unrelated or distant using this specific library. We can go with ADB instrumentation and containerization using Terraform, Liquid-Base, or even the Aura operator, which I just mentioned. So it will be around containers, right? That session. We can also do an ORD-specific session where we go and create REST microservices with existing data on the database. And we can also go do a live demo on how to create a Grafana dashboard to monitor a specific autonomous database, okay? So based on your answers, that's what the next session will be. Thank you.